Hello people, today we are back with another video. Today let's try solving the problem of the day. The problem of the day is minimum swaps to group all ones together 2. So uh, there's part 1 for this question. So let's try doing both of them together. I'll try explaining that question too through this question itself. Let's try solving this question now. Let's read the question first. A swap is defined as taking two distinct positions in an array and swapping the values in them. So imagine there's a 0 here and there's a 1 here. Swapping these two means making it 1 0 0 1 1 1 0 0. This is called swapping. It's obvious. And then there's a catch in this question. It's a circular array. And I'll explain what circular array is. So imagine there's a 0 1 uh, a 0 1 0 1 1 0 0. So circular means the 0 here in the rightmost point and the 0 in the beginning point, both of them are actually adjacent. That's what is called a binary circular array here. Nums return the minimum number of swaps required to group all ones present in the array together at any location. So the question here is trying to ask us to do an operation on this nums. I mean, not the operation. It is telling the number of operations it takes to make sure all the ones are together. And here, that was the part one question. In the part two question, you can see even if the one is in the leftmost side and the rightmost side, it means they're together. So that's what we are trying to do. And let me try explaining it on the notepad. Yeah, here is our first array. You people can see here this is the first test case. Okay, let's try finding how many operations it takes to swap this to make sure all the ones come together. So here you can see there's a 1 here and there are two ones here. So I'll just take this 0 and I'll place this 1 here. So then you can see how many operations it took. One operation. This is the first test case. Okay, let's check more test cases. We can get some intuition. So you can see there's three ones here, there are two zeros here, and there's two ones here and the 0 here. Okay. The first thing that comes to your mind is you would be like, okay, let's put a 1 here and let's put a 1 here. Let's swap these two elements and then all of them are together. That's what you would think. And the number of operations would be 2. Okay. But then there's one more way to do this. The other way to do this is imagine I put one more, I put 1 here and then I put 1 here. Just the operations are still two, but there might be a chance wherein if you do it in the circular way, in the sense you make sure you put the ones in the end, and you may get a smaller number of operations, and that is the actual answer. That is one more way. And now here, this question you see, this test case you can see 1 1 0 0 1. What do you think it is? Yeah, it's already all the ones are together. The operations, zero operations are required to be done here, because this one and this one are adjacent and then these two are anyway adjacent. So then one more, the last, let's check our custom test case here. We have 0 1 0 1 1 0 and so on. What will we do here? I would check a window in which there max, like, more ones are there. Here you can see there are two ones that are together, then there's one here and there's one more one here. So then I will replace this one with here, one here, and then here, and then one more here. This would take two operations. So I was thinking of one approach. Let me, here you can see in the question there's 0 1 double like 3 1 0 0 and 1 1 0. So I think I think we need to find we need to think about what we are trying to find here. We are trying to find a window of size. Imagine this question. I'll copy this here. You have this array. So this array is there. So what I'm trying to do is I'm trying to find a window of size. How much? How many ones are there? 1 2 3 4 5. 5 ones are there in this. So then I want to swap. I want to find the number of gaps in between. How many are there? 0 and 0. Two gaps are there in between. One way of doing this is like there's number of ones in this window. Okay, I'll start the window here. The window starts here and the window ends here. How many ones are there? There are 5 ones. And how many zeros are there? 2 zeros are there. Just two swaps. So in two swaps, you would get your answer. This is one of the cases. And then let's try with the next. Let's try this test case. There is 0 1 0 1 1 0 0. So I would have a window of size 3. So because there are 3 ones here. Wait, I'll zoom in. So there's, wait a minute. Yeah, here you can see there are three ones. So we are using the three sized window. So I'll start the window here. How many zeros are there? There are two zeros and there's one one. So the minimum number of zeros is like two here right now. And then I'll move my window forward. It's 101. How many zeros are there? 10 is there. So that's like really less. And then let's just keep the count. And then now I'll move my window forward. 0 1 1. How many zeros are there? Only one zero is there. So this question can be solved by just doing one swap on it. So the answer would be 1 for this. You guys can see this is the first test case. I'll try coding it up, then I'll re-explain the question again and how we approach the solution. So first step would be, so the step 1 would be to find number of ones to assign the, it's a sliding window question basically. Okay, this is the step 1. So let's initialize. Only if the nums of I is equal to 1, that's when we increase our window size. Now we have our window size ready. So now we'll do one thing. So what we'll do, we will so we will do a tree computation. So I'll explain here. Wait a minute. I'll tell what tree computation is. Imagine this. We have this. Let's not go with this. Okay. I'll take this test case and I'll do it. Yeah, I have this. Let me write the indices of each one of them. Yeah, we have these indices. Now we're trying to group all the ones together. Oh my bad, this is already group. I mean, this is the wrong array. Let me bring the actual. Yeah, now you have this. So now let's do the pre-computation. So how many ones are there? Ones are equal to 1, 2, 3, 4, 5. So there are 5 ones here. So let's start with our window size of 5. So I'll just keep the arrows such that number of ones are 5. So it will end up till the index 4. Yeah. So these are there. This is size 4. And how many zeros are there? I'll just keep the window size. Window size for each. Window 1. Window 1 has how many zeros? Window 1 has 2 zeros. And then let me move my window forward. Now window 2, let's check how many. Our window 2 has 2 zeros again. Next window 3, how many zeros does our window 3 have? Our window 3 also has 2 zeros, and then let's move it forward, and our window 4 also has 2 zeros. Now our window 5, this is our last window. Our last window has 3 zeros. Yeah. So what would the answer be? So two zeros. Let's just take this window, the first window. There are two zeros. So you just have to do two swaps to get the answer, right? So the answer would be the maximum, I mean the window size, which is equivalent to how much? The window size is 5. 5 minus 2. How much is 5 minus 2? I mean 5 minus 3, which is equal to. So 2 is the answer for this question basically. I'll try coding it up. So let's try coding the question. Okay, now we are done with pre-computation. Now let's initialize the number of ones. So ones are 0 initially. So I'll iterate right from the beginning to the window size. So if one, again, if the this is there, and if at all, and now we are done with pre-competition. Now we start moving our window forward. So entire equals to 0. I meant from 1 it goes on to what? It goes on up to the nums minus the window size. We are moving it forward. There'll be a point when you have to stop because you no longer can allocate a window of that size. This is that. We're starting from 1 and it goes on to nums of size minus window size. Okay. This is the time we would compute our answer. So I'll just keep an answer equals to int max so that we can keep a track of the minimum values. Answer equals to the minimum of, yeah. So the number of ones, what would be the number of ones minus, so it would be so it would be the number of ones minus the size, the window size. This way we can find the number of zeros that are there. Okay. Now as we are moving our window forward, if at all the nums of I minus 1, if it's equal to 1, then we would subtract it from our ones variable. And if our nums of I plus 1, not I plus 1 exactly, it should be I plus the window size. The window size, if it's equal to 1, then 1's plus plus. This is what we're doing here. And if it goes out of bounds, we have to make sure we cover that also. Let's just do a normal run here. And let's check if any errors are there and let's try resolving them. We're getting a minus 2. Let's check what is going on here. It should be window size minus the number of ones. We were taking an extra window into consideration, so there should be a minus 1 here. We didn't yet handle the case wherein it's a cyclic array, then our test case would fail. Yeah, so these two are passed. This is already sorted, but we still are doing it. Yeah, so now we'll try resolving that issue wherein it's a cyclic array, and how do we find it out? Yeah, so let's take out that array wherein it's already sorted. Yeah, so in this case, not in this case exactly. Wait, I'll bring out the test case when the cyclic one was possible, wherever our test cases have failed. Yeah, so just imagine this is the array that's given. So this array that is there, so it's already sorted. So then what we will do is the window size is 3. Okay. Now what we would do, we would just make one more copy of this and We would add it here. That's all. And now if it's window size, we would be checking a subarray that such that it has the size 3 and the maximum number of ones. So then you can see here the minimum number of zeros you need. So this window is there. So the answer would be 0 here. So because it's already sorted, I mean it's not sorted, I mean all the ones are already grouped in a cyclic array. Let us try coding that part also now. I'll create one more temporary array. Or we'll do one thing, we'll add the nums to, we'll create a duplicate vector. And then auto extemp, and then x, I would just add it here. Now if you solve it, I hope we get the right answer. That got accepted. Let's try submitting it. There'll be some more errors. Let's try resolving those edge cases which you haven't handled. What is the wrong answer? Yeah, if it's a single element. So then if at all, if the answer is still int max, then I would return a 0. So now I'll submit. Okay, it got accepted. I'll try explaining the code again. Here you can see the step 1, what we did is we found the number of ones so that we can have a window size. So here the window size was found till here. Yeah, here the window size was found. Then next we counted the number of ones, and then whenever and we made sure we made a duplicate of that given vector, and we made it into two copies and combined both of them so that we can handle the cases wherein it's a cyclic array. And then after that, what we did was we did a sliding window of a fixed size, which is the window size that we found here. And then as and when we find the number of ones, we subtracted from the window size and found the number of zeros. And then we made sure that we get the minimum number of, we get a window so that it has the minimum number of zeros. Then we kept on having, tracking it with the answer variable. And then if at all it's still max, we would return 0. Otherwise, we will return the answer itself. That's what is going on. Thank you for watching.